So now let's move forward to session 3, sustainability assessment. Considering that we are much delayed, Professor is going to step ahead for giving a great talk. So just a brief introduction to Professor Elena SEMENZIN. Professor is an associate professor in environmental chemistry at Ca' Foscari University of Venice. She holds a PhD degree in environmental sciences at Ca' Foscari, completed with a Marie Curie fellowship at Wageningen University. Her research interests are environmental risk assessment for both traditional and emerging pollutants along the life cycle of products and processes, including the safe and sustainable by design concept, sustainability assessment, and more specifically, assessment of environmental sustainability in the circular economic context. So thank you once again for accepting our invitation. And yes, please go ahead. Thank you.
Thank you for the invitation and for the introduction. Thank you for allowing me to present, because then later, unfortunately, I have to join another meeting. So today, what I was asked to present is an experience about assessing chemical safety and sustainability of innovative bio-based products. Here at Ca' Foscari University of Venice, we do have a group working on the implementation of safe and sustainable by design framework at the Department of Environmental Sciences, Informatics and Statistics. Well, we all know the background, so I will skip this because we are already all familiar with the safe and sustainable by design framework. Just one word about the fact that, of course, we need to use the principles of the safe and sustainable by design framework along the innovation process. But then, as it's written in the document by the Joint Research Center, we need to assess whether our products are safer and more sustainable than those that we are aiming to replace. So we need to go through the 5 steps that were presented before by the colleague of Itene that are mentioned in this framework. A framework that is actually going through a testing and also consultation process. So we are waiting for the new version of this document. So as I said you before, the aim here for me is to present just an example of what we're doing in our team, and the example is related to a European project, which is Green Art, just closed 2 days ago. Green Art was a 3 years project, Horizon Europe project, in which the aim was to develop innovative bio-based solutions for art restoration. So a very specific and particular context. But it's a nice example to see how the SSBD framework can be tailored to specific applications. So what we did here, we developed the Green Art assessment approach. So starting from the 5 steps of the SSBD framework and considering the technological readiness level of the solutions within the project and the specific context, the specific, let's say, sector that we were addressing, we developed a specific approach. The first, this is including 3 stages. The first one is about hazard assessment. The second one is called screening sustainability assessment. And the third one is a life cycle sustainability assessment, including LCA and LCC. And how we proceeded, actually in the beginning, the partners, the developers in the project had a long list of possible solutions. So we screened them first with hazard assessment, and then only most promising solutions went to the second stage for screening sustainability assessment, and then to the third stage. Of course, most promising means in terms of functionality and safety and sustainability. So the 2 things must be combined because, of course, functionality is extremely important in the innovation process. So the first step is about hazard assessment. We already heard that in this we have to consider to consider hazards related to human health, environmental hazards, and also physical hazards. And the SSPD framework is indicating us how to classify the different substances and materials according to different groups. The first one, it includes the substances of very high concern. The second one, the substances of concern. And then in the third group, we do have all the other substances. How we proceeded? We proceeded according to a tiered approach. As I told you before, actually, we had a long list of ingredients in the different formulations, and the product developers, the partners in the project, were exploring different solutions. So we had to support them in this stage with iterative classifications of this according to the hazard assessment. And so the final aim was to classify all the substances according to these three levels that are indicated by the Joint Research Center in its document, and then use this classification also to classify this method of classification also to classify the mixtures, so the formulations that were under development. Of course, our regulatory framework is mainly the classification, labeling, and packaging regulation, which provide the self-classification approach for mixtures. So just to provide an example, this is the kind of information that we could collect, and according to the classified hazards and the criteria that are in the SSPD framework, we were able to classify, to point out the different levels of classification, indicating which were the substances that was better to avoid because they were they were in the level 0, so below the cutoff criterion suggested by the European Commission. And then since we were receiving formulations as ranges of percentage composition of different ingredients, we're playing with that in order to provide the final classification to the developers, along with the explanation of which thresholds were bringing that specific classification, so that they could understand whether to, if it was better to avoid specific ingredients or to reduce the percentage composition of the specific ingredients, how they could improve their solution, their formulation, in order to reach a better level in terms of hazard. Then the second stage was about screening sustainability assessment, as mentioned before. Here we had to develop a semi-quantitative methodology because the technological readiness level was quite low. And so we decided to go for a questionnaire. It's a questionnaire that is covering all the different stages of the life cycle. So from raw materials to end of life. It's covering three different aspects that you can see here in this slide. So functionality, sustainability, and safety. And this is done through a set of questions. For each question, it's possible to answer among 5 possible answers, from the worst one, bad, to the most to the best one, which is indicated as excellent. So it's a guided, let's say, questionnaire in order to derive then scores for each questions that are for each question which is related to a specific criterion. This questionnaire that we developed is compliant with the Eco-Design for Sustainable Product regulation. And I must say also that the questions under functionality and sustainability must be answered by the product developers, while the questions about safety were answered by ourselves based on the information on the classification of hazards done in the previous stage, and on exposure assessment that was conducted in the project. And then we combined hazard and exposure through two tools, HTOC-TRA and ProScale, in order to derive risk classification. So this risk classification was then included by the team implementing the SSBD framework into the final questionnaire. So just to show you then the kind of result that we can obtain by applying this questionnaire, here you can see a graph in which we do have the results for the benchmark formulation already in the market, and then two innovative formulations developed within Green Art. And then you can see all the criteria that we prepared, so that are included in the questionnaire in our tool through specific questions. And then you can easily see in which cases the innovative formulations are performing better than the benchmark formulations. And so on one hand, it shows to the product developers where they're already very successful in their new formulation, and which are the possible improvements that could be brought to these new formulations, or still some hotspots that should be targeted. It's possible through a simple average also to show the results according to life cycle stages, so to understand which is the stage in which we do have the main issues still to be solved, or according to sustainability aspects. And again, here the question, the answer we want is whether the issues are on functionality, sustainability, or safety. Then, according to the 3 stages approach that I showed you before, we do have the stage 3, which is about life cycle sustainability assessment. And here, of course, we could assess only the most promising and developed products, because to perform life cycle assessment, LCA, and life cycle costing, LCC, we do need to collect a lot of data in order to reduce the uncertainty in the results. Still, since the technological readiness level was quite low, we had to apply a prospective LCA methodology. So as you can see here, we use, of course, the methodological guidance of the Safe and Sustainable by Design Chemicals and Materials published in 2024, but we use also the technical report titled Prospective LCA Methodology for Novel and Emerging Technologies for Bio-Based Products. So what we did was to model the industrial upscale of the most promising solution. And according to the information provided, we were able to derive results for both LCA and SCC. Here, well, I think I can skip this slide on what is life cycle assessment and say that for this specific application, we decided to use the product environmental footprint method, which is the one that is recommended by the European Commission and allows to calculate 16 different impact categories that you can see in this slide. And here I decided to present the results only for life cycle assessment, and the way in which those results are presented is the way in which the way that is suggested by the SSBD framework, actually. So to compare the innovative solutions, in this case, they are indicated as design A and design B, to a benchmark, and to calculate a difference in percentage. Then based on this difference, there is a score that is assigned to each solution. And you can see that when the improvement is above 40%, then the score is 4, and the color is the blue one. And then you do have the different scores until 0 and the different color codes here. What can we see from this table? We can see that the different impact categories can be classified according to this method. And then we can also see the results grouped according to the areas of interest that are suggested by that are indicated by the environmental footprint method. So climate change, pollution, toxicity, and resources. We can see that in this case, for these two innovative solutions, the results are quite similar. The same for climate change, for toxicity, resources. The only difference we can see is about pollution. And we can see that the alternative called the design B is obtaining a score that is quite low because the pass-fail threshold is at 3. So actually 1.6 is quite low. So we were able to go through these results, go back to the different impact categories, bringing to that result. And you can see here a focus on pollution area of interest in which the different alternatives are compared to the benchmark, and in which also we highlighted which is the contribution of the upstream phase compared to the core. And here, since we are talking about bio-based solutions, actually the upstream phase is providing a huge contribution compared to the core, so the production itself of the formulation. And in particular, there was a difference in the composition of design A and the design B that could justify the higher value in impact categories like eutrophication, acidification, and so that the pollution results are at the end not that positive. So this was interesting for our partners to understand again where to put the attention in terms of further improvement. But as I said, this was just a specific sector of interest, although, I mean, also the questionnaire that we developed can be extended to other sectors, can be tailored to other specificities. There are a lot of sectors of interest under the eco-design for sustainable products and regulation. You can see this list of final products and intermediate products. I wanted only to point out that combining also the digital product passport, textile is one of the most interesting sectors. It's also the first priority product class to be included in the ESPR and energy labeling working plan that we have in the next 5 years. And this is just to mention you that we are continuing as a group to develop specific methodologies to implement the SSBD framework in different contexts. And the two ongoing projects that we do have at the moment are related to the textile sector. One is BioSustex, which is specifically dedicated to the development of safe and sustainable bio-based textile, in which we are exploring also the inclusion of the absolute sustainability assessment. And the other one is a CBE joint undertaking. It's called Surf to Green. And here the aim is much broader because we aim to develop bio-based surfactants that are applied not only to the textile sector, but also to personal care, home care, industrial detergency, and also agriculture. And in both of them, we are again implementing this framework that is quite complex, trying to understand which are the specificities of the different sectors and application, how we can really build new methodologies according to different level of technological maturity, according to so different tiered approach. Linked to these projects are also this Sunrise project in which we are involved. We are coordinating actually, which is about advanced materials, in which there is also a decision support tool that is under development for implementing the SSBD framework. This is our group, quite large group at Ca' Foscari University of Venice. And with that, I thank you for your attention.
Well, thank you very much for your nice talk. We have time for questions. Yes.
Yeah.
Can you hear?
I can hear you, Carla, but then
Vem cá. Vais falar a
Thank
seguir.
you for the presentation. So I would like to hear from you, which is the most important challenge in implementing the sustainability assessment. Since that's my field of work, I'm interested to know from your experience in the projects, which challenge do you think it's more difficult to tackle as a researcher in order to support more sustainable products?
thank you for the question. Actually, in this specific project, I must say, as I was mentioning before, it was availability of data, because when you are at very low technological readiness level, then it's really hard to collect primary data, and you have to include a lot of assumptions, and if the data in a model are not very precise, then also the results, the risk is that the result is very is not robust. It's not robust enough. But I think it's very important to make the whole process transparent, also with the product developers, so that they can understand which are the strengths and the limitation of the approach. And another, if I can add, is really linked to the bio-based products, because most of the people I'm talking with have in mind that when we are using bio-based products, actually we are surely improving the sustainability. Where we really need to assess sustainability along the whole life cycle. And then, as I showed before, the upstream phase can really contribute a lot to the final sustainability. So it's important to explain that safety and sustainability are two different things, and in sustainability the whole life cycle must be considered, including also the agricultural phase for bio-based products.
Thank you very much.
Thank you.